See Lindelof videos, calculus, implicit differentiation, practice. This is the last one I'm going to do tonight because I'm starting to get a little whatever. So let's see what this looks like. If you take a look at this and you tried to get this all worked out, you'd see that this thing doesn't graph very well. So let's see what this thing might look like. Um, on the exam, this is most likely, in my opinion, to show up on the multiple choice section, and they're going to ask you to differentiate at a point, and they are not going to use the words implicit differentiation. You're going to have to look at this and realize that that's what you're going to have to do. So my notation looks like this. I'm declaring that I'm going to take the derivative of this whole thing, and by saying that, I'm saying I'm going to take the derivative of this piece and that piece, and finally this piece out here. So two of the three pieces are super easy to take the derivative of, and one of them is not too bad at all. So let's just do this quickly. So I said I was going to do this in order, so the first thing I'm going to do is take the derivative of 5x cubed. So 3 times 5 is 15, right? X squared, and that is the derivative of that, right? I'm also going to take the derivative of this piece and this piece. Let's look at this piece just for a second really quick. Because ddx of a constant value is 0. So this just goes away, right? This is just, right, equals 0. So I'm not even going to bother with that, right? If this was 5x squared plus 2, the derivative of the 2 would be 0. So hopefully that's cool with you. This, though, when you look at this, I hope you can see this is actually the product rule, right? It's negative 3x times y. So we're going to use the product rule, and the product rule says that we take the derivative of the we take the first part of the function, the first part of the equation, which is negative 3x, times the derivative of the second part, and the derivative of y with respect to x is dy dx. That's the notation, right? So remember, we are using the product rule. So there's a plus sign here. Now we take the second part of the equation, which is y, times the derivative of the first part. And so the first part is this negative 3x, and its derivative is negative 3. So I think we can agree this is going to look like 15x squared is equal to negative 3x dy dx minus 3y. I'm just cleaning it up a little bit, right? So there it is. Remember, our goal is to get dy dx by itself. So I'm going to add positive 3y to both sides and get 15x squared, right? I get 15x squared plus 3y is equal to negative 3x dy dx. And what does suck about this as I look at what's going to happen on this problem is, look, so I'm going to divide both sides by negative 3, right? Negative 3x, right? So I get 15x plus 3y divided by negative 3x is equal to dy dx. And you're like, that wasn't too bad. However, on the AP exam, especially, God, it sucks so bad, especially on the multiple choice part, they're going to expect you to clean up your algebra. So I'm going to have to factor this crap right here. So at the top, I'm going to factor out a 3. So, right, 3 times 5x plus y, right? 3 times 5 is 15x. 3 times y is 3y. You see it? Over negative 3 equals dy dx. Oh, dude, I almost lost that x. Sorry about that. Good. And then I'm going to simplify this, right? So I'm going to end up with this. I always bring the negative out because that's the way it always looks on the test. 5x plus y. I'm sorry, 5. I thought it's 5x squared. It is 5x squared. Thanks for telling me. Right? 5x squared plus y all over x, right? So somebody was starting to mark the point on the video where I screwed that up. So got it, dude. Hey, thanks for watching. Super tired right now, so thanks for watching. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. I appreciate it.